Hello friends, my name is Bharat Modi, working as an associate prof in Department of Electrical Engineering in Swami Keshanand Institute of Technology, Gramothan, Jaipur. In this topic, we will discuss single phase transformer equivalent circuit and various kind of test which have been performed on this transformer. Okay, this topic is related to the third SEM electrical engineering electrical machine. Subject code is 3EE5A. Now, in first slide, we will discuss equivalent circuit of single phase transformer. Actually, in this case, we will discuss a practical transformer which have secondary winding resistance R2, secondary winding leakage reactance X2. Similarly, in primary winding, R1 is the resistance and secondary primary winding reactance is well known as X1. There are shunt branch parameter also available in primary winding, which is well known as R0 and X0. Usually the value of R1, X1 and R2 and X2s are very low as compared to R0 and X0. If this is an ideal transformer which has been shown in green line, in this case R1, X1, R2, X2 values are 0 as well as R0 and X0 are infinite value. Now the secondary winding current, which is also known as load current, is I2. Similarly, the referring of secondary winding current on primary side is well known as I2 dash, and no load current which does not depend on load well known as I0. One thing should keep in mind, I0 and I2 dash, the phasor sum of both current equal to I1 if nodal analysis is used. Now we have several parameters like R0, X0, R1, X1 and R2, X2. These parameters can be found out with the help of various tests. So we will start with open circuit test. In open circuit test, we have secondary winding and load is completely disconnected, so that the secondary winding current is 0. So not referring of secondary current on primary side. So only primary side, no load current, which is well known as I0 in the previous circuit shown by I0, is available in this circuit. Second thing, this test is performed at rated voltage on primary side. In order to protect the whole circuit, fuse are used. Normally DPST, double pole single throw switch, is used primary side, as well as transformer which is used to electrical supply, and wattmeter which is used to measure the no load losses, as well as voltmeter on primary side, as well as meter on secondary side, used voltage and current respectively. Now auto transformer is used here because we want to supply rated voltage, and which can be measured by voltmeter V2. Similarly, this test similarly this test Similarly, this test also classified like short circuit test. In short circuit test, there is secondary winding which is completely short circuited, so heavy current is flowing in secondary side. So one thing keep in mind, in order to reduce this current, we will provide fraction of voltage on primary side. Similarly, in this circuit, fuse is used to protect a double pole single throw switch, which is also used, and auto transformer also used for provide rated current, not rated voltage. Second thing, there is a secondary winding which is completely short circuit, so that very fraction of voltage which is required to flow the rated current on primary as well as on secondary side. Here wattmeter is low power factor wattmeter, and the range of current is very high if I compare with open circuit test. So we can say that this circuit is more dangerous. Now the key features of both tests we will discuss in this slide. Open circuit test is used to perform two tasks. First is find out the value of R0 and X0 and No load losses, though no load losses mostly constant in nature. Second thing, series parameter can be found out with the help of short circuit test. Series parameter is R1 X1 and R2 X2. Similarly, some factors which also keep in mind, like rated voltage rated voltage is used uh, during open circuit test, and rated current is used, or rated current is flowing during short circuit test. In order to convenience and protecting point of view, high voltage side is always used for performing short circuit test. It means secondary winding which is short circuited must have low voltage winding. Similarly, low voltage winding test is performed in open circuit test, because in this test rated voltage is required, and it is beneficial to provide rated voltage on primary side. So these are the basic key features of both tests. In this lecture, that is sufficient. Thank you.